This is a Carboline production.
On this episode of The Red Bucket, we are joined by Ron Brashear of BYK, a global supplier of specialty chemicals and additives. Together, we discuss the chemistry behind additives and their use in the paint formulation process. We also cover how additives can be designed to help the coating perform to the end user's specifications. All of that and more coming up next on The Red Bucket. Here we are again on another episode of The Red Bucket. And Paul, I feel like I learned a little bit of something about you on this trip this time.
Learn that it's maybe not safe to listen to everything that I tell you?
Yeah, ladies, I thought Paul was a fine, upstanding citizen until last night.
Right? Anyway, that's the voice of Ron Brashear from BYK. But before we get into the full introduction of Ron, we have some business to attend to. Everybody listen to this show. When Paul says, hey, look at that, don't do it.
All I was doing was sharing the visuals.
Yeah, and what I will say is I saw things that I can't unsee.
Right, and I didn't want to be the only one who couldn't unsee it.
Well, apparently we're too trusting. So anyway, if you guys can't tell, our next guest here is Ronald Brashear from BYK. Ron, why don't you tell us a little bit about BYK?
BYK is a global manufacturer of coatings additives primarily, but we do service other industries as well. We produce many different types of additives, surface additives, rheology modifiers, probably best known for wetting and dispersing additives. But if there's some type of additive used in many different types of processes, we're just a global producer of those types of materials. Headquartered in Wallingford, Connecticut.
In Connecticut. And there's an interesting story about it being headquartered in Connecticut and another famous BIC being headquartered in Connecticut as well. Could you kind of go down that road about the BYK versus BIC and how it can even be more confusing than we realize?
Oh, yeah, absolutely. Technically, it's neither. I think the German pronunciation is like book.
Oh, well, see, there you go.
And so we're confused. But little known fact is that BIC, the pen manufacturer, is actually located in Connecticut as well, maybe 3 towns over from BYK.
Right.
And as part of our training protocols, whenever there's emergency and you dial local officials or even 911 from your cell phone, on our script card, we have to specify that, this is so-and-so calling from BYK.
Right, because the pen manufacturer
is more recognizable.
A little bit more known. I mean, not everybody uses paint additives, but everybody uses pens.
Yeah.
Yeah.
But why don't you tell me a little bit about your role with BIC?
Within BIC, I serve as one of the 5 what we call end-use managers. The market segments that I cover are actually the marine and protective coating segments. I will have counterparts covering the aerospace, automotive, general industrial, powder, special coatings, can and coil, deco, construction, and wood, I think, are the 5 end uses that are represented in North America.
And you mentioned can and coil, and that brings up, it's amazing how many people don't realize that there is actually a coating on the inside of their soup cans of whatever it is, or their fruit cup cans, the metal cans. And that
soda, beer.
Right.
I mean, there's a lining there to protect that.
Paper coatings. I mean, if you think of like things like Chinese delivery, those little boxes, those contain coatings as well.
Yep. Yeah. It's amazing how far the minute details that our industry actually goes into that most people don't ever consider. And the fact that you have identified it as an entirely different division for how your additives work or which additives you might be looking at is just proof to that.
One could say it's the subtle differences.
Yeah.
And that's really why BIC follows this kind of like end-use philosophy, is where you have specialists in a given area, so they are more in tune with the nuance of dealing with the additives and with specific formulation types.
Mm-hmm.
I mean, whereas, I may be involved in more your epoxy type formulations, those folks are going to be more involved in, melamines, acrylics, polyurethanes, depending on how they're going to be used in those respective use areas. I mean, so it really brings a higher level of knowledge, expertise to those formulation types, and that's really why BIC has adopted the formulation in-use concept.
Yeah.
So we've been kind of talking about this, and if you guys haven't caught on, we're talking about the actual formulation of the coatings that you use every day, specify every day, the different aspects that go into what it takes to make the coating do what you need it to do. And additives are really one of the ways that a paint manufacturer can tweak a coating formulation. Ron, why don't you talk a little bit about the role of additives in formulation for a coating?
What we consider additives to be are products that perform certain beneficial functions, but the key being is they do those at low use level in formulation. I mean, you can achieve some similar results with maybe resins or solvents, but their use level will be higher, and they also have more negative impacts when you consider the benefit of the effect that you're trying to achieve and the use level of the other material that you're trying to use. So additives are just really there to provide a specific effect at low use level while maintaining, we'll just say, any negative impacts on the formulation.
Right. Like when you look at an SDS, it's like the 1%ers and the 0.5%ers of the formulation.
It really is. And so when you break down a paint formula, kind of the category, most simplify it, we're looking at 4 different groups where essentially you have rocks, glue, solvent, and other.
That's a pretty oversimplification, but it works.
And when you look
say
at
that
rocks,
one more time.
Yeah, rocks, glue, solvent, and additives or other.
Okay.
And when you look at the rocks, we're talking about things like pigments. We're talking about the solids, the parts that give us some color or that give us some feel, those kinds of properties. Sometimes it's extenders to make it flow and level out smoothly. That's what the additives that BYK makes work with. Then the other part being the glue. That can be anything from a polyurethane to an epoxy resin to latex paint. It's glue.
Yep.
And then you have your solvent, so whatever your carrier is that's bringing all of this liquid to the substrate. And that can be anything from, in epoxies, it might be MEK or xylene or acetone or what. And in latex paint, that's water. And then that last little bit, and when you're looking at a chart, a graph of what these are, those 3 components add up to 95, 98, 99%.
Mm-hmm.
And that last percent are the things that a company like BYK adds in to help those work better, more efficiently, and really give you that final touch from here's a rough formula of something to here's a final product that a customer can enjoy using and use properly.
Yeah, I think one of the things that you said there that I always kind of was an epiphany that I had at one point in my career was you brought up glue, and you were talking about specifically within the coating that the resin is glue, but I don't know, it was probably 10 years ago that I came to the conclusion that all coatings are glue.
Yeah.
Essentially. That it's basically glue with color.
And that really brings us around full circle into the idea of when we start with a paint formula, we start with a glue with its maximum adhesion, sticky properties. And then everything we do decreases that property, especially when you put things like rocks into it. And so that's where the additives from a company like BYK work to help us improve those qualities of those rocks to make them work better together. When I say rocks, we're talking typically now microscopic.
Sure.
We're talking about powders and that kind of thing. So it's a matter of what kind of additives do we use to make those wet out better, or dispersants. I'm leading you right into it.
You're leading me right into dispersants. One of the things that BYK is known for really globally is we're a world leader with regard to wetting and dispersing technologies. When you talk about those rocks in formulation, you're talking about your pigments, your color pigments, and you're looking to optimize your tint strength from those pigments. You're looking to get the best stabilization so that all the work that you've done to disperse those pigments to primary particles isn't undone on shelf stability. So you give the coating excellent shelf stability, the best color development in terms of transparency, also the best transparency if you have a system that is properly dispersed and stabilized. That's what wetting and dispersion additives do.
And, that's a really neat perspective to bring up, is how we're talking about something that's put in at fractions of a percent, and it is literally the components that help shelf stability in many of the cases. So when we talk about dispersing and wetting agents, we're talking about the ability of essentially a powder to stay properly suspended in a liquid. And that's what these wetting agents do, is they help it become more saturated so that it's uniformly wet.
Dispersed in the system. Yes, correct.
And then it stays there. So when we put the paint on the shelf, and that's when we talk about shelf life. In some products it's months, in some products it's years, but it's a matter of how long can these agents help keep it in suspension to keep it uniform and easy to use.
Yeah, easy to use is really the goal in the end. When you produce a product, because you don't know how long it's going to sit on the shelf. So if it sits a month or 6 months, you want the end user to pick that product up, use it, and get the same performance, whether it's been there a month, whether it's been there 6 months, or whether it's been there a year, depending on the formulation type.
And so to that point, it makes it important for you as a representative to be able to understand what it is we're using. And I guess we come back to, that's why you're in protective coatings and marine group, because the types of particles we use are fairly similar. So you'll know those additives are going to work differently with the large particles we use in protective and marine coating kind of things, is very different to what they would use on the inside of a food can.
Correct. I mean, food compliance is always a big concern, but when we look at just the different types of formulations that you see in the P&M space, you could have shot primers, you could have high build tie coat primers, and top coats. So between those three respective systems, we have products that we have history with that we know perform well with certain types of resins, certain PVC ranges, certain applications, and we know that of the portfolio, these are the ones that typically work best in these areas. And so those are the ones that I'm most familiar with. Mm-hmm. If you look at our portfolio, we probably have on the wetting and dispersing side, probably over 100, 150, 200, just wetting and dispersing additives.
Well, that's what I was going to get to, is the differences. and when you have 150 of them, there's a lot of differences, but we're not just talking about one universal dispersant that fixes everything and makes it perfect, right?
Well, I wish we had it, because then we would own the market, because everyone wants a universal product. Unfortunately, it doesn't exist. No. Universal products do not exist.
Right.
But what we try to do is using very different chemistries to produce the wetting and dispersing additives. We have just 6 different classes primarily that we produce additives in. And with those chemistries, they tend to work better with different types of binder chemistries.
So the type of additive you would use would match up with whether it's an epoxy or an acrylic or an alkyd. You would determine which dispersant to use based on the.
Correct. You could always say, when you have this many products, the worst thing you can do is someone says, hey, we have this product, just recommend this product. That's the worst thing you can do, because you spend a lot of time having people chase something that may not be in their best interest. So we always have the conversation, or it's best to have the conversation, is, hey, what type of system are you working in? What product performance attributes are you trying to achieve? Or what don't you want to happen? Because sometimes the additives can have impacts in certain areas, so it's good to know what you can tolerate and what you can't, but also how are you processing said system as well.
Sure.
And that has an impact on the recommendations that we would make as well.
Way back at my beginning, I was a formulator when I started in this industry. I was going through making my first formula. We were working on stuff. I was working on latex paint at the time, and I was chasing, and I had some properties I couldn't fix. I had a thickening property that wasn't working right, no matter how much thickener. And I finally, we reached out, and I reached out. It was a BYK additive at the time. Reached out to our rep, and we talked about it, and it came down to literally it was a pH issue. And it was amazing how I decreased the amount of the thixotrope that I was using, or the additive that I was using, decreased it exponentially when I made a minor adjustment to the pH of what I was working with. And all of a sudden, everything worked exactly like it was supposed to be. But I chased it for weeks. I was just all over the place, everybody I was talking to, and that little nuance, reaching out to somebody like yourself, this was way before I knew you, but reaching out to somebody like you to say, hey, here's what we're working with, here's where we're at, and a company like yours signs, you work with all the NDAs so that we can actually talk with you and say, hey, here's what I have, here's what I'm working on, to get those nuances of how will your product work best to get the results that I need? And that's really what we look for when we talk with a company like BYK for those additives.
And that's, I think, the advantage that, well, we're not the only company that do things like this, but we just think that we are one of the better companies at providing this level of support for our customers, so you can support your customers. I mean, we go as far as even doing things like we'll do technical service requests, maybe to help you out, where we may screen products in advance of, instead of sending you 10 samples to screen to maybe find the best additive, what we'll do is we'll do the pre-screening for you, narrow that down to maybe where you're only looking at 3 additives. So there in time speeds up your development process as well. I mean,
Right.
So we'd like to do some of those steps to make sure that we're making the best recommendation that we can to give to you, so you're not wasting your time.
And I think we're going to get into that a little bit more later, but I think it's safe to say as we get into most of these additives that a lot of them will have, the dispersants for sure depend on the generic type, but much like a tank lining recommendation, whichever one of these additives that we're going to use, there's a series of questions that you need to know the answer to in order to make sure that they get the right one. So,
Correct.
And I think so. We talked about dispersants and wetting agents that are dispersants. I think the next category of additives that we really should talk about that are similar but different. Let's talk about surface additives.
Okay, surface additives. What we always say, you can have the best formulated product known to man, but if you can't effectively wet the substrate that it's supposed to protect, that coating provides no benefit whatsoever.
Sure.
So when we think about surface additives, we can break those down into different functionalities within surface additives, but we are primarily concerned initially about substrate wetting, the ability to get the coating that you produce to lay down on the substrate to provide that protection. So that's really important.
And, and that is really the distinction. As we were getting ready to talk, one of the things we looked at was, are we talking about wetting agents to wet out the pigments that are in the coating system, or wetting agents to wet out the surface?
Right. And they're both called wetting agents.
Right. And Ronald's answer was yes.
Yeah.
It depends.
Right. But at the same time, when we talk about surface additives, we're not only just talking about flow on the surface, we're talking about adhesion as well. And the flow itself would be an adhesion promoter, but
not necessarily.
Well, not necessarily, right? Because there are adhesion promoters.
There are adhesion promoters. When we talk about flow, we specifically think about having the most level film that you can have. Right. When you say flow additive, that's really what you're trying to achieve, the flattest film.
You're looking for that sheet of glass on the top, right?
Correct.
Right.
But that's what we deal with when we say flow, or when I think of flow, that's what we mean. Substrate wetting is entirely different. That's a spreading rate, or
Sure.
spreading.
Sure.
They are actually opposite of each other. Spreading and flow are opposite. So you can then be in a situation to where you have something that is really effective as a substrate wetter, you get excessive flow.
Okay.
And then what happens, any imperfection in the surface is telegraphed through any subsequent coat that's applied to it.
With too much flow.
With too much flow.
Yeah.
But in order to achieve the best leveling, you actually are trying to achieve a minimum amount of surface area. So you want the thickest film possible. And these things are tied to the relationship between the surface energy of the substrate versus the surface tension of the coating that's going on said substrate.
Okay.
And I can say, in order for a coating to effectively coat a substrate, it has to be equal to or less than, the surface tension of that coating has to be equal to or less than the surface energy of the substrate.
Scaling that phrase down, we're talking about how big is the bubble when you drip a drop of water onto a table, a wall, whatever it is. Does it keep a bubble form and nice and round and you can see the curved edges, or does it smooth out and lay out across the whole thing? That's what we're talking about, is how do we control and change how big of the term I always use is meniscus. How big is that curvature that's on the sides of a bubble, whether it's a solvent bubble, a paint bubble, a water bubble, whatever it is on the surface, how much of that until it rolls out the sides?
Correct. Or you can also sometimes look at it, what is the diameter of the the
Right.
the larger the diameter of the drop, the better the spread.
Yep.
Or you have enhanced flow in that case.
Yep.
And is this how we're promoting adhesion, or there's another that's altogether different?
Well,
still?
adhesion promoters are altogether different. I mean, you're looking at additives that are really contain a functionality of this one that's going to be part of that molecule has to have an affinity for the substrate, and the other portion has to be binder affinity. So you have to have something that's going to be compatible in the binder system, but at the same time wants to have an anchoring ability to the substrate. So that's when we say adhesion promoters, that's really what we're talking about, is something that is specifically designed to have an anchoring effect of the coating to the substrate.
Okay, so you're chemically bonding to the substrate at this point, or an attempt to, or helping the coating attempt to do that.
Yeah. And you usually see those things in some issues of like coatings that are going to go for glass, plastics, or even you're going to go over things like galvanized. Sometimes you may want an adhesion promoter in those systems to promote that, depending on the resin chemistries that you're using to go over that substrate.
We've talked about the need for flow, right? But that's a little bit different than flow additives and how they're used. Could you discuss the flow additives and how they're different than the additives that we've already discussed?
Well, flow additives are primarily, from my perspective, are used to generate the most uniform, flattest film that you can have when you're looking for things like that mirror finish, glass-like finish. That's really where you're going to specialize and really concentrate on the type of flow additives that you're going to be using. That's really what they're designed to do, is really improve that film surface appearance.
So in a lot of cases, what you're going to look at is, like when we talk about it over steel substrates, it's a little easier because we're usually talking about microscopic thickness differences of the substrate. When you do your abrasive blast profiles, we're talking about a 1 mil anchor profile, a 2 mil anchor profile. So we're looking at thousandths of an inch. But those could be very different if we're talking about something like a concrete coating. When we're talking about a surface profile that could range in full fractions of an inch, quarter inch, half inch, in the just difference of the profile. So the amount of a flow additive that we would need, or the type of a flow additive, is going to be very different in a product that we're looking at doing over concrete, for instance, primarily over something that is primarily applied on steel, which is why a lot of times you'll see a question come in of, all this talks about all steel, can I put it on concrete? Well, yes, but you're not going to get the same final appearance in concrete that you will in steel as easily. There's probably going to be things that we can do to help adjust it and improve it a little bit, but when we look at the additives that were put into it, it was meant to do adjustments of a thousandths of an inch, not halves of an inch.
Yeah, correct. I mean, and ultimately looking at the probably potential differences in specifications that you're looking for as well. Do you need a high definition of image? Do you need ultimate clarity, or do you need the smoothest film? For concrete, we're probably going to say maybe not, depending on the application.
Right.
Some structural steel, you won't, depending on the application. So really, these things are always going to go back to what is the application performance requirements that the customer is requiring, and then we can make recommendations based on that, depending on how your current system is performing.
And that's a good point to say. And the way your company is broken down, that your automotive or your airplane finishes are different than your industrial protective and marine coating divisions, primarily because we're looking at different particles, different systems that are used, because like you mentioned, depth of image is something that's important on an automobile, and it's not so important on structural steel.
Correct.
So we're using different types of particles, different size particles, therefore we need different additives, different flow agents, and different dispersing agents than you're going to use in something that is so microfine milled as you would in an aeronautical coating or an automobile coating.
Yeah, the goal is to tailor the additive package to the end-use application that it's going into. Like I said, for most protective and marine applications, we don't need that absolute surface appearance. We typically don't. We're more concerned about the other aspects of the coating, the protective aspects. That's what we're more concerned about, and how our additives impact those areas.
Mm-hmm. Right.
So when we're trying to achieve that perfectly smooth surface when our flow additives, it's really a bummer when we come across things like bubbles. Yeah. And so sometimes when we see those bubbles, we have to pivot and use different additives called defoamers. Let's talk a little bit about defoamers.
Oh, yeah. Defoamers are, from a analytical or formulation point of view, they're the biggest headaches because you actually have to do the work just based on how defoamers work fundamentally. I mean, so for instance, one of the things that you'll often see is that someone has used a defoamer and they've had good success with it. And they automatically think this is the best thing ever. And so that
put it in everything.
That product will make its way into everything that formulator touches.
Yep.
Just because they had a positive experience with it. Defoamers work on a principle of being incompatible in your system. Okay, and that's something that you have to remember. If you have a compatible defoamer, you don't have a defoamer because they work on the principle of incompatibility. So depending on the level of incompatibility in your system determines the efficiency of said defoamer.
Do these incompatibilities lead to the occasion where if we give, let's say we give a field use of, here's a thinner that has a defoamer in it, and occasionally you end up seeing, I'm going to say, a film or a hazy appearance on the surface when they're done. Is that due to excessive defoamer that's possibly incompatible at the level that it's being used at, and you're seeing it just kind of sit at the surface because it didn't have anything else to do?
That could be depending on that, or it may be, for instance, that could be something like using maybe like a mineral oil or something that may be blooming or coming to the surface. So some of the defoamers will actually contain wax particles. Okay. Depending on the types of chemistries they use to make the defoamers. I mean, so it's possible, but really they're usually not there in high enough concentration to really cause a significant coverage of the surface. What you'll usually see as a defect will be in terms of, we'll say, cratering. If a defoamer is really strong and incompatible in the system, you'll have craters or holes within that film just because you were not able to effectively disperse the foamer effectively enough, so it'll coagulate and you'll have craters on the surface. So that's the typical response that you'll see if the defoamer is really too strong in the system.
So that really brings us full circle into whether it's the chemist who's putting it in at the formulation standpoint, or if it's been added to a solvent or something that you can add post-add in the field. It's important to pay attention to the directions that you're given. If it says don't exceed 10% or 20%, there's a reason, and it's because it could take, and what it's trying to solve, it could make it worse.
Can we talk a little bit about the use of anti-corrosive pigments in coating?
I mean, absolutely. I mean, they're there to help passivate that surface and provide long-term corrosion resistance. But in order for them to effectively work, they have to be uniformly dispersed throughout the system and then maintain that uniform dispersion throughout the life of its storage stability. I mean, that's one of the aspects that the wetting and dispersing aspect comes into as well, because we disperse those rocks and we disperse those specialty rocks and we keep them uniformly dispersed. I mean, so without those, where you're looking to improve the corrosion resistance of your coating, you're going to use anti-corrosive additives.
When we look at an additive, to help maintain uniform dispersion within the coating in the bucket, and then we have to look at something that's also going to help it flow out properly, wet the surface properly, the pigments wetted in the coating properly, and then you think of the very last step of what happens, or I guess probably second to the last step, is we take that uniformly dispersed liquid and we put it through a spray tip at 2, 3, 4, 5, 6,000 PSI through something that is 0.8 of an inch, 0.7 of an inch in diameter, and we literally atomize it. We break it down into the smallest particles that we can physically break it down to, and keep our fingers crossed that it goes back together when it hits the surface.
No, there's more science than that. There's no finger crossing. We know that it's going back and being the same.
But in reality, that's what we're looking at, and that's what we want the secondary, we need to wet it out in the system, but we also need it to wet out on the substrate, because as these microparticles hit the substrate, we need it to uniformly come back together into a unified liquid at the same flow additive thickness and the same surface wetting properties to be able to make it uniform as it goes across.
And I think to a certain extent, if you've been paying attention for the last half hour or so, you can see that when you have a good additives guy,
right,
and a chemist, and you put them in a room together, they can just go and they can just talk.
Oh,
you guys have even tried to stay on topic for this podcast, but I can see you both wanting to talk more about like specific things that we aren't really applicable here.
And even when we're saying this, you have to realize there's more than one way to get there.
Right.
We can get there. I can get there more than one way. It's just which way is going to work best for you.
Right.
Exactly. And I think that's what I want to talk about. And we talked about it a hair earlier in the episode, but it's the important partnerships between a paint company and the additive supplier and kind of what you guys do. So you hit on a lot of it, but let's kind of summarize it again and talk about why should a paint company be calling you?
To make their life easier, ultimately. I mean, you can do the work yourself, or you can lean on the expertise of a company and individuals who have worked with these additives, along with competitive additives in many different types of systems, and understand fundamentally how these things work. And having that fundamental understanding allows me to okay, well, what do you want to achieve? I know there's more than one way to get there. Which route do you want to take to achieve that endpoint? So that's kind of like why you work with us. We have product expertise from the products that we produce. We have formulation expertise from my 30 years in the industry. And the other end uses are maybe not as long in the tooth as I am. But, they've been in the industry for quite a while as well. I mean, so we have that industry expertise. And a lot of the end use managers actually come from the industry where they've held positions at other paint companies.
Sure.
And they leverage that expertise as well. So from everything that we've been able to see, from commercial formulations to look at even when we do laboratory formulations and work with, things that on a concept basis shouldn't work, but if you actually take them to the laboratory, they do work. And this is sometimes the formulations that we end up having to address when we deal with certain customers that, they'll provide a formulation, obviously under NDA, that we'll look at, and I'll look at it and I'm like, why is that in there?
Sure.
Or why are they doing that?
Sure.
That doesn't work. And when you put the formulation together, it actually, in that instance, it actually works.
And that brings up two parts. One of them being from a paint applicator standpoint, when they're having a problem, when they hit a sticking point, when they have a question, they're going to come to somebody like my group to ask the questions. And when we have questions, my first stop is usually to our chemists, and we talk about stuff. You're their first stop for how are these additives working.
We get fundamental breakdowns of sometimes what we're dealing with. We don't actually get the absolute, what's the chemical structures and things like that. But fundamentally, we can kind of this is kind of what we're dealing with. And then we pass that information along to the chemist. And I said, you can make the best decision on, you've got group A, group B, or group C type of chemistry. They're all going to function reasonably well in your system. What are you trying to do?
And and that brings me to the other thought that I had of, as coating systems become, let's call them more high tech, and it's still
you're
just
going to be
paint
using more additives.
That's exactly it, because you can look at a formula and say, fundamentally, those shouldn't work together. That shouldn't be something anybody wants to use. But then when you do it, it works great. And one of the things, though, that you find is if anything is slightly out, whether it be a substrate temperature or environmental conditions or too much thinner or not enough thinner, when something gets slightly out of whack, you have catastrophic effects because everything has been put in on just a refined edge. But it gives you a great result when it's used properly. And it's a lot of that is we found the right combination of additives or mixture of ingredients that gave that unique property that somebody was looking for.
There's this misnomer in the industry that everything's the same. Whether it comes from Carboline, whether it comes from one of our competitors, it's the same thing in the bucket. And everything that you've heard about today are the differences. Because to a certain extent, polyamides are polyamides. Phenalkylamines are phenalkylamines. There are differences. But when you start looking from one company to another, it's what additives did they use to make the end user's life easier. That adds cost sometimes, but I would say that those are the subtle differences between the different coatings. It is literally this small percentage of the formulation that we're talking about with these additives. Would you
that is absolutely correct. When you look at it, if everyone used the same resins, same solvents, then the art of formulating and how the formulators are able to express themselves will be through the use of the additive packages. That's really where the formulators shine. You have a Rembrandt in your lab, you didn't know it, is when they can use those additives, that gives them the best chance to put every little bit of feel, every little bit of nuance to their formulation. That's also where you're able to add some robustness to the formulation. You mentioned earlier that, you found that it works on a very specific set of situations. Sometimes the additives will give you some breadth to that formulation and some robustness that it will extend maybe proper application.
Yeah.
And under different conditions.
And I think you two could go on forever, and it's time for me to pull the cord. Ron, thank you so much for coming on. But before we let you go, we do a thing on this here podcast, and it's called our 4-question segment. So, Ron, if you had a hobby, what's your hobby?
I guess now it's kind of like golf. It's kind of
Right.
like my hobby now. I suck at it, but it's kind of something that keeps me humble.
So, sports. We know golf is a hobby, but do you have a professional, semi-professional, college, a team, a sport?
College team.
Okay.
I am a local Louisvillian, born and raised, so the University of Louisville is near and dear to me.
All right. So let's pretend like for a second golf is like baseball or the WWE and you have a walk-up song. So
Rockstar.
Imagine it going...
Rockstar.
Coming up on T number 1.
Rockstar.
Ronald Brashear. And he's just saying Rockstar by Nickelback. That one?
Yeah, that'll work. Or other versions.
And Paul, give him the last one.
So, TV show, movie, what's your favorite one-line movie, sitcom, whatever it is?
It's good to be the king.
Yeah.
Mel Brooks, History of
Yes,
the World.
absolutely.
There we go.
Yeah, I used that phrase just the other day.
That's enough for this episode. Ron, thank you. And
No, thank you.
Coming up next is Tech Tips.
You have questions, they have answers. This is Tech Tips.
Hi, I'm Anthony Allegra, product line manager for Carboline. I was going to tell you a little bit about thinners today and how we select which ones we're going to use. There are various speeds or evaporation rates that you would use to select the thinner. Typically, that's going to be something like a slower solvent for hot weather or a faster solvent, obviously, for colder weather. And then in those different speeds of evaporation, there are also sometimes additives that might retard the cure. If you need a little longer open time, such as brush and roll, there might be an additive that helps to defoam, which you tend to get with a sticky urethane, or there's products that may give you a little better flow and leveling, things like that. So just remember, when you see all the different thinners on the PDS, don't just use the first one in line. Make sure that you understand which one is right for the application you're going to do. Consult with your Carboline sales rep and make sure you try to get the right one for the application.
Once again, thank you for listening to the show. We had a great time with my buddy Ron. For Paul, I'm Jack. We'll go ahead and see you next month.